mean, who does not hate word problems? I hate word problems, but that's not the case anymore. In just few seconds or minutes, we are going to see how easy this word problem is. Looking at this problem, the equation of motion of a particle is this function. We have this function given s is equal to t cube minus 3t, where s is in meters and t is in seconds. So we are being asked to find velocity and acceleration as function of t. So what is the velocity functions of t, right? So this is simply a derivative, like same thing what we have done previously. We can apply the difference rule here as well. So this is simply we are finding the derivative of t cube minus 3t, which is equal to derivative of t cube minus derivative of 3t. And I'm pretty sure if you have watched my previous videos, we can see the pattern here. This is basically a constant multiple rule being applied here and power rule over here. So the derivative or the velocity as functions of t is simply 3t square minus 3, right? Correct, right? You guys know how I get here, right? So 3 derivative of t is what? It's 1 times t to the 0, and which is anything raised to 0 is 1, so it's simply 1. So 1 times 3 is 3. Now let's look at the acceleration. Acceleration is simply the derivative of velocity. I also call this as a double derivative. I don't know if you guys familiar with this term. So acceleration as functions of t is simply the derivative of velocity. So this is going to be derivative of 3t square minus 3. Okay, here let's again apply the difference rule here first. So this is derivative of 3t square minus derivative of 3. Now guess what? Can already tell here again same constant multiple rule being applied, and this is a constant rule here, derivative. And we already know derivative of constant function is what? 0, right? And derivative of this is going to be simply constant multiple prior 3 times derivative of t square, which is 2 to the t raised to power 1, right? So this is going to be 3 times 2t, and which is equal, okay, let me just write down here as well one time. It's minus derivative of this constant 3, derivative of 3 is what? 0. So the acceleration as functions of t is 3 times 2 is 60 only. And now we are being asked the acceleration after 2 seconds. So we already have this, right, as functions of t, and t is equal to what? 2 seconds. And I'm pretty sure you know already what we are going to do here. We are simply going to plug in into this function, in this acceleration function here. So which is going to be after 2 seconds, this is going to be 6 times 2, which is equal to 12 meter per second square. And remember, this is acceleration, so you don't forget to write the units as well. Okay, now let's look at this. The acceleration when the velocity is 0. This is a bit tricky, right? The acceleration when the velocity is 0. So what we are going to do is when velocity is 0. So we have this velocity function, right? 3t square minus 3. Find the acceleration when the velocity is 0. So what is, so now that velocity is 0, so this is going to be 0 is equal to 3t squared minus 3, and simplify this. So it goes to the other side. 3 is equal to 3t squared. Simplify this further. Divided by 3 on both sides. We are left with 1 is equal to t squared, which is equal t is equal to square root of 1, right, which is 1. So what we have is t is equal to 1. Now this is what we are finding the velocity, sorry, acceleration. So we are going to plug in the value here in the acceleration function now, 6 of t. So acceleration when the velocity is 0, that means that t is equal to 1. The acceleration is going to be 6 times 1, which is equal to 6. So this is your meter per second. See, already forgetting. And this is exactly what I'm going to do in exam as well. So make sure you're writing units, otherwise they're going to deduct your points. So acceleration when the velocity is 0 is 6 meter per second square. So I'm really hoping that these videos are helping you out. Thank you for watching.